Okay, I'm recording now. Can you guys see on Discord as well?
Yes.
Okay. So, hello everyone for those who are here on Discord and also for those who are watching this later. This is my presentation on sustainable farming practices and policies in response to climate change. So, there's going to be three parts to this presentation. First, we're going to go over climate change and its impacts on agriculture. Second, climate smart agriculture. And third, some farming policies implemented to combat the effects of climate change. So, it's a no brainer that climate change is changing the way that the Earth has its precipitation patterns, its temperatures, causing extreme weather events. And one of the ways that this affects agriculture directly is when drought incidence and severity is increased because of the said elevated temperatures. And this is going to cause crops to be more stressed. It's going to reduce the yield of crops. It's going to cause drier soils. And it's going to deplete surface and groundwater resources because of the drought. So, an example of this is from 2013 to 2016 when all of California was experiencing a severe drought. Here you can see on the right there's a graph where from 2013 there's the orange and into 2016 there's the brown. The drought area is extremely severe. And even though the drought was still going on, I guess life still goes on, if you will, and agriculture society, like, it's still going on, and they were overdrawing groundwater and the aquifer levels were severely depleted. Too much groundwater being drawn can cause saltwater intrusion, as California is a coastal area. The same conditions that cause drought can also increase the incidences of wildfires. So even though they're a natural phenomenon, climate change can threaten to increase the frequency and length of the wildfire season, and it can also make the size of the fires bigger. This can cause a positive feedback loop where the climate change is making the wildfires more severe, and the fires are burning all this organic matter, and it releases carbon. And by releasing the carbon, you're making climate change worse, and then the fires get worse. It's horrible. So that's a positive feedback loop. Why does this matter? Because almost over half of the land in the United States is forest use land and grassland and pasture land, and that's where the wildfires can happen in these land areas. Also, these ecosystems and land support livestock production, so the populations of the livestock will be greatly affected. So you could say goodbye to the cows. Okay, on the flip side, climate change can also cause extreme precipitation. Let's look at this graph from that shows the percent of land area in the contiguous United States experiencing one day extreme precipitation events. So it's fairly steady until the 1980s. And then once you get past 1980, you see that the percentage of land experiencing a lot of rain has gone up a lot. This trend is only going to continue. So climate change is expected to increase extreme precipitation, and this causes two things. It increases rainfall erosivity, which is the potential for soil to be eroded, and also the sediment transport capacity of surface runoff. And both of these increase total soil erosion and sedimentation into receiving water bodies. Why does this matter? Because when the soil erodes, it's going to cause a large loss in carbon and nutrients stored in the soil. And once again, this is going to create a positive feedback loop where the soil gets released and then the carbon gets released and then it goes into the atmosphere and then it just accelerates climate change's effects, which is really horrible. And this is an image of soil runoff. What about the water resources? Well, about the soil being eroded, it's gonna go into the surrounding water bodies. And that's going to cause nutrient runoff from the agricultural lands where you're spreading fertilizers and applying it all over the land. And that's going to cause hypoxia in the water, where it's a low oxygen environment because the fertilizers give too much nutrients to the water and the microbes, the algae consume it and then they die too fast. This is gonna cause fisheries to decline. So you can say goodbye to your fish and your clams
No.
and your shrimp.
No.
What about the soil? So with extreme precipitation, you're gonna also choke up the soil and cause soil hypoxia because the oxygen diffusion is being impeded as well. And this is gonna suffocate the roots and damage the crops from reduced root respiration and nutrient uptake. And the flood of water also disrupts the microbial communities, and that also influences the nutrient cycling. What about the water? So, man-made carbon dioxide emissions that are increased more and more causes ocean acidification. In short, carbon dioxide reacts with water to release more hydrogen ions that reduces the pH of the water and makes it more acidic. And this can affect species such as coral reefs, where they require bicarbonate ions to build themselves. And this is going to affect the starfish and the scallops. You can say bye to them because they use coral reefs as habitat. And from climate change, rising atmospheric temperatures are going to also warm up the seawater. Why is this important? I will mention this in a moment. It's because it's going to reduce the dissolved oxygen concentration. So warmer water is less soluble than colder water. It's going to take in less gaseous oxygen. Also, the dissolved oxygen concentration is caused by increased stratification. It's where the warmer layers on the top of the sea are less dense, and they're gonna resist mixing with the colder, denser layers. So deep sea ocean is not going to get as much oxygen. Also, because the water is warmer, the metabolic rate of organisms are increased, so they consume more oxygen. So they're consuming more oxygen, and there's less oxygen. So it's really hot, and everyone is suffocating. It's not good. So we just went over a bunch of ways climate change is affecting agriculture. What is being done? Because trust me, this was me when I was researching all the impacts to prepare for this presentation. Agriculture is vulnerable to climate change, yet also contributes greenhouse gas emissions. There has to be a better way to grow food. Introducing climate smart agriculture. So, climate smart agriculture is a term first coined in a 2010 report by the FAO, which is the Food and Agriculture Organization of the United Nations. And this report showed that agriculture is affected by climate change, but at the same time, the greenhouse gas emissions from agriculture also make climate change worse. So, climate smart agriculture is an approach of farming that aims to 1. Increase or maintain productivity, 2. Enhance resilience to climate change, 3. Reduce greenhouse gas emissions. It's not necessarily high tech or anything brand new. It's just building upon practices already in place with the goal of adapting to the climate or preventing more impact and that's what makes it climate smart. Okay, so this is a non-exhaustive list of some examples of CSA. For the soil health and carbon sequestration, there's no-till farming. Usually when you till the soil, you're flipping around the soil and you're disturbing the soil. This way, if you don't till it, it's going to retain moisture and reduce erosion. You can also plant cover crops to protect the soil in between growing seasons, and you can also add nutrients. Agroforestry. If you integrate trees and shrubs in the farmland directly, you can sequester carbon, and that way it's going to improve the soil. What about the water? For drip irrigation, this is technology where you send the water directly to the plant roots, so you're not wasting water. But you can also have a very simple method, which is just have vessels to collect rainwater and save it for when you're having drought periods. What about the livestock? You can reduce the methane emissions from livestock by adjusting what you're feeding the animals. You can also compost the animal waste and use it to make fertilizer. Diversification. You can do genetic engineering or also breed different crop varieties that you can withstand drought, heat, and salinity. And you can also diversify the actual crop planting. Because monoculture is bad. Well, do you guys remember the Irish famine? That was
Yeah.
basically so basically all the potatoes died because of monoculture. They only planted one specific crop. So if you diversify the crop planting, you can prevent great losses like that, a spread of diseases and whatnot. For technology, an example of renewable energy used in agriculture is solar pumps. You can power the irrigation pumps, as seen in the picture, instead of using fossil fuels. You can also do a specific type of farming called precision farming. It's where you use GPS, drones, and remote sensing to monitor crop health and soil. And this way you use only enough water and fertilizer. So drip irrigation is one technology that you can use in precision farming. I want to talk about one specific CSA practice, which is controlled release fertilizers. And they're basically these grains of fertilizer with a resin or polymer coating that delays nutrient release from the fertilizer core. Traditional fertilizers are usually urea based and cause problems such as nutrients, they just evaporate in the air, denitrification, and sometimes the nitrate just leaches into the groundwater. If you look in this figure here, the controlled release fertilizers release slowly over time because of the resin coating or the polymer coating. It takes time to decay over time, and the conventional fertilizer release is much faster. From an article I read, I'm going to quote this. The expected release of 80% of nutrients was observed between 28 and 46 days for polymer-coated urea and polymer-coated sulfur-coated urea, compared to uncoated urea, which releases nutrients in a few hours. So clearly there's a huge difference, and I think controlled release fertilizers are super cool. They reduce the loss of nutrients. They're much more efficient in the distribution of nutrients. But I will say a drawback is that these polymers sometimes are made with plastic, polyurethane and polyethylene. And microplastics in soil is another problem. or just in the environment, but here we're talking about the soil. So we learned about different CSAs, and they're not just one solution. Solutions to combat climate change is not going to be one silver bullet, and the policies are similar. The American Relief Act of 2025 was signed, which extended the Agriculture Improvement Act of 2018, also known as the 2018 Farm Bill, for 1 year through September 30th of this year, 2025. And what this bill basically does is offer a bunch of different programs to offer either technical or financial assistance to farmers to improve their operation and also combat climate change. So, under the Farm Service Agency, there's the Conservation Reserve Program, which pays farmers and landowners for converting environmentally sensitive land to vegetative cover. This is voluntary, and basically, when they're enrolled, farmers and landowners get annual rental payments. By incentivizing people to plant native grasses, trees, and restore riparian buffers, water quality is improved and soil erosion is being controlled. Under the Natural Resources Conservation Service, we have the Conservation Stewardship Program, which incentivizes farmers to go beyond their current conservation efforts. So an example of this is if you're already using cover crops, you can be suggested to try a deep-rooted cover crop to break up soil compaction, and therefore you can improve the health of the soil. And then boom, you get paid $4,000. That's the minimum annual payment. Another program under the Natural Resources Conservation Service is the Environmental Quality Incentives Program, which offers contracts to implement funded projects that will address natural resource concerns. So while researching, this came up on Google, and I went on Reddit. And first, from the USDA website, it said directly if you schedule an appointment with the Natural Resource Conservation program branch, a conservation planner goes on your property to talk about your goals and resource concerns, and then they recommend a tailored plan of conservation practices or activities. So on Reddit, people discussed their experience with, I'm gonna call it Equip, and one person got a well that was funded under drought relief. Another was paid to fence their cattle away from the creek to avoid manure leaching into the creek. So there are some mixed reviews, but most people said that they're like, it's free money. So I was like, okay, that's cool. So we learned about climate change impacts, we learned about CSA, and we learned about farming policies. What are some tangible things that we can do to take away from this presentation? I think the best thing we can do as students and constituents and just ordinary people is that we can prevent food waste. 30 to 40% of the food produced for human consumption is just thrown away. And you would think this would be from the farms, from the restaurants, from the grocery stores, but no, most of this waste actually comes from households in the United States. I think reducing the food waste is important because it's going to reduce the carbon footprint and methane emissions. When you throw away food in the landfill, especially, it doesn't break down normally, and it releases methane. And methane is a much more potent greenhouse gas than carbon dioxide. Finally, I think after all the hard work that the farmers do, they would be sad if we wasted their food. Just something to think about. And that is the end of my presentation. Thank you.
Yay! Nice. I learned so much. Felt so much.